Good afternoon and welcome. I'm Jamie Thornbury from ORM and I'll be your host for the GRDC Society of Precision Agriculture livestream on variable rate technology. During today's presentation, you are invited to join the conversation at any time using the chat feature. Today's program has been designed with significant time allocated for questions and discussions, so please take the opportunity to drop some questions in. I'd like to introduce Angelique McAvoy, who is the Executive Officer at SPAA, who will provide a brief introduction.
Hi, I'm Angelique McAvoy and I'm the Executive Officer at the Society of Precision Agriculture Australia. As we are meeting today virtually from all around Australia, I would like to begin by acknowledging the traditional owners of our country. I acknowledge the Whadjuk Noongar people of the Perth region from where I am meeting with you today, and I acknowledge all the traditional owners of the lands upon which our agricultural community reside and operate from. We pay our respects to their elders, past, present and future, and I extend that respect to any Aboriginal and Torres Strait Islander people who are here today. Welcome to all participants who have logged in. It's great to see that we have such a strong turnout for today's webinar. I also welcome our three panellists, Colin Hinze from Pinion Advisory, Tim Neale from Data Farming, and Reuben Wells from AgLogic. I would also like to acknowledge Brent Perkins from SPAA, who has done a terrific job coordinating today's webinar. Thank you, Brent. And a very special thank you to GRDC, who have funded the VRT project, which also includes a series of hands-on workshops around the country and today's webinar. SPAA would also like to acknowledge our principal sponsors, John Deere, Case New Holland Industrial and Elders. The GRDC and SPAA VRT project was developed against the backdrop of a large spike in urea prices in late 2021. You have no doubt seen that urea prices have retreated from their late 2021 highs and have fallen back to more acceptable levels. However, farming practices that serve to reduce even moderate input costs will see improvements to the bottom line. Furthermore, primary producers that employ more efficient practices now are better served to protect themselves from future shocks, and history tells us that future shocks will happen. SPAA is Australia's leading independent advocate and facilitator for increased research, extension and adoption of precision agriculture, delivering industry-wide value across different sectors. SPAA is all about guiding participants in the agricultural industry to farming success through the tools and practices embodied in precision agriculture. Using data to inform decisions about variable rate inputs, hence using inputs more efficiently, underpins the concept of precision ag. This webinar aims to demonstrate why this is important. It will also outline the building blocks required for effective VRT, as well as outlining next steps. So it's my pleasure to introduce you to our panellists. Colin Hinze. Colin is a senior agribusiness consultant with Pinion Advisory and provides farm management advisory services to a diverse range of clients and industry groups. With over 25 years of professional experience working with both corporate and family businesses, Colin brings a wealth of knowledge and skills relating to leadership, strategic planning, and continuous improvement. Tim Neale from Data Farming was named Australian Agricultural Consultant of the Year in 2018. He has over 25 years' experience across Australia and internationally, 20 of which has been spent running his own business. Tim's strong ag tech focus has been driven by an evolution from CTF, auto steer guidance technology, elevation and water planning, yield mapping, variable rate, soil mapping, and satellite imagery. And finally, Reuben Wells. Reuben established AgLogic as a specialist business providing technology support to Tasmanian farmers on the completion of his PhD in 2010. Reuben has developed expertise in mapping services that provide value to AgLogic's clients, including variable rate fertiliser and irrigation support, drainage planning and land capability mapping. I'll now hand you over to Colin.
Thanks, Angelique, and I'd like to extend my welcome to everyone that's joining us today. To get us started, just want to set the scene about why variable rate is an important addition into the farm management practices of modern agriculture. Our focus today is around optimising profit, and profit being constructed by obviously the cost of inputs, the yield that we can attain, and the quality and price for our product. The graphics meant to illustrate that we can increase our effort without necessarily gaining profit. There's a sweet spot where our profitability peaks, and we're looking to optimise the combination of our cost, yield, and quality to optimise that profit. So in the context of VRT, we're not necessarily talking about maximising yield, and we're not necessarily talking about minimising cost. It is finding the optimal. For variability, to look at different paddocks, this graphic is intended to show how 3 different paddocks might be naturally occurring on any given farm. The blue line represents a paddock which has minimal variability, the orange line, moderate variability, and the green line, quite a lot of variability. If this was a soil attribute like soil pH, for example, each paddock has the same average soil pH. However, the blue line represents a paddock where the range of pHs is slightly below to slightly above average. In contrast, the green line represents a paddock where there's a large range of low pH areas and high pH areas. We take that through to a management strategy for liming. It's quite feasible. There's significant areas of a paddock which might be getting too low an application, other areas where the application is not necessary or in fact even could be causing harm. So this is where we're looking for variable rate technology to tighten our application around that variability. The cycle of precision agriculture, working from observations of yield, vegetative indexes, and soil attributes, for example, combining those with an evaluation, analysis, understanding where that variability is and what might be driving it, to lead us into targeted management decisions, our variable rates or our variable treatments. It's a cycle because we need to continue those observations to understand how that targeted management has impacted our production system. So if I was to go back a step to those graphs, what we're looking to do with variable rate and with creating zones is to turn that highly variable paddock into smaller areas or identified areas which within themselves have less variability, less range around their average, rather than one broad average for a larger area. To optimise our efficiency in a farming context, we're not only looking to apply the right amount of the right product in the right place at the right time, we've got the complexities of using the right equipment or the right practices, if you like, and underpinned by the right data. And to really get the most out of variable rate technology, the green highlighted attributes there, the right amount in the right place, underpinned by the right data is what's important. So what is the right data? As an introduction, that really, it starts with what data do you already have? And there's a couple of visual examples here on the screen. Auto steer systems are collecting point data all the time that could be used to generate your digital elevation model map, for example. There's a lot of information that already exists just in that step alone. Moving around clockwise, you could combine that elevation data with some proximal soil sensing, an EM38 in this example, to start to understand how terrain and soil texture or soil type differences could be occurring. Combining that information with yield data, yield maps, remote sensed imagery, satellite imagery, or aircraft-based imagery is how you start to build the picture of potential zones on your farm and in your paddocks. The next question is, what is the problem you're trying to solve? And making sure that that data is relevant to the issue you're looking for. If it is a structural issue, you'd be looking at soil texture and type, for example, and ground truthing in that basis. If it is a nutritional issue you're looking for, then obviously the type of information that goes with these potential zones is quite important. And the third attribute, the third question to ask yourself is, does it make sense? Is this consistent with what I understand about my paddocks already? Does it relate to what I know when I'm driving in these fields? And does it match what the potential seasonal forecast is and how I know my soil types tend to behave? So that's an important thing to keep in mind as well. And it's important to note that the right data, the right place and the right amount all interrelate with each other and are interdependent to an effect. The right data helps us understand where the right place is to identify those zones. And then from those zones, we need to generate the right data to understand what is driving our variability so that the right amount can be calculated to apply. So they're all interrelated and important to all work together on. So pulling that all together, there's a number of different ways that you could use variable management practices. And as an operator, you can enter this pathway at any of these examples here. But it depends on what your problem is you're trying to solve. It could be a structural issue, which is a building block, a long-term solution around drainage potentially, that has a long-term effect on your management of the paddock. There could be multi-season impacts around the use of lime and gypsum to where there's a multi-year effect of those management changes. And then in the pointy end, if you like, the thinner end of the wedge is where you're looking to address within-season crop variability around phosphorus and nitrogen, for example. So the maps that you have are only as valuable as the actions it drives. They don't do us any value if they're a laminated placemat on the side of the desk. It's important that we use them to drive actions. And it's also important to make sure that you spend your time and limited resources on where you can influence change and have actionable data. So with that, I'm going to pass over to Reuben now to step through a couple of examples. Thanks, Reuben.
Thanks, Colin. We've thought a few examples now, just demonstrating some of the pathways that we've been involved with in our respective roles might be useful, both to illustrate the processes that Colin's just talked about, but also to highlight some of the real world opportunities, but also challenges that come in the process. One key point to get across is that there's no right data. There's no one single process that is going to suit every situation or every season. There's differing needs in every crop and every paddock, and you need to have a process that responds to that. Having a cookie cutter approach is never going to work for this kind of thing. So a bit of thought is needed. So one example that I've gotten, the two examples I've got today, both come from the same property, but they're quite different in approach. We have a lot of grass seed production down in Tassie. A crop which is uniformity is really important for maximising the return the grower is going to get. So uniformity and maturity at harvest is critical. We had a lot of a really wet start down here this year, so finding that there was quite a lot of variability in our paddocks depending on where was wet, where was dry, and how much stress it had from waterlogging at the start of the season. This particular crop, we went into the grower came to me with the challenge of how do we even up the maturity. We looked at a few different data sources. We used Sentinel satellite data. We also looked at using some drone imagery. Now, he happened to have a farm, one of his farm workers who was right into drones and had some really good imagery from there. We ended up being able to pull that drone imagery in and got a great base map. So that was our right data solution ticked. We used a number of tools on the way to get there, and choosing the right tools for the job is a pretty important part of this, because when it works, it actually works really easily, getting a plan into a variable rate spreading implement. But it's a little bit of a balancing act a lot of the time, and if you don't have the right tools for the job, it can very easily bring the whole process unstuck. I use a tool called the PCT Ag Cloud, which is developed specifically for doing precision agricultural work. And there's others around there, but that's one that we've found pretty useful. We integrate other software in as needed. Normally, the process doesn't need too much external software, but we found we needed a little bit of extra manipulation of that drone imagery to get it into PCT. So my business helped him get the data in. Once it was in, we were able to leave the grower to handle the rest of it himself. The actions he took, nitrogen applications. In this case, we were cutting back the nitrogen on the high vigour areas and topping it up on the low vigour areas to try and give them a little bit of a kick in the pants and get them to catch up. And we also used some growth regulators where we use those to delay maturation in those high vigour areas. So here's some pictures of what we were seeing. So you can see his drone vigour map there. Now red's just low vigour, blue's high vigour. We've got a growth rate prescription map which we've produced on the right, and that goes out to his sprayer. And similarly, we've got a nitrogen application map there, and you can see we've reduced the rate of nitrogen on those high vigour areas. Worked quite well in terms of the follow-up observation process. We have grabbed some later satellite imaging, and you could see there was a much more uniform variability across the paddock. There is yield data. We haven't brought it in because he happens to have a header that's possibly Fred Flintstone would have thought was old. It takes a little bit of manipulation to get it in. We'll get that later on. Now, another example from the same farmer. In this case, he was interested in a little bit getting in a bit earlier, instead of dealing with in-crop variability, dealing with the inherent variability in the site using variable rate fertiliser application, which is probably a bit closer to the topic of the workshop and provides a good example for today. He was looking at variable rate liming, phosphorus, potassium. Now going into that, we had a little bit of data available with some elevation data and some satellite imagery, and we had considered using those for some zoning, and you can see where, well, I'll zoom ahead in a moment and show you the correlation we had there. But we've also done a lot of other work in this paddock. So it had previously been land plain, so we've smoothed the surface to maximise drainage. We looked at using that topography, but instead we chose to use a gridded soil sampling pattern because there was just a few unknowns and we couldn't justify a zonal-based point selection for our soil testing. And I'll get onto zoning and gridding at the very end of these case studies. So on the left there, you've got some NDVI imagery, again, Sentinel satellite imagery, so a vigour map, if you like. And on the right, you've got an elevation map, and you can see there's a really strong correlation in this paddock. The low areas were very low vigour, the red areas were very high vigour. In this case, for the really simple reason that it actually went completely underwater, or half that paddock was flooded. So correlation was fairly tight, but nevertheless, we went out with our point data. We're trying to increase our understanding of these paddocks to work out when we can zone and when we need to use the gridded soil mapping. So this was also a case study for that. So we've gone on out there and we've sampled 2 samples per hectare. You can see all those points on the left. Now on the right, that's a pH, the surface pH map. Now, if I go back to our previous map, there's only coincidental correlation between those two data layers and our variable rate, our pH map. There's a zone on that top side, the north side of the paddock, which is showing quite high vigour but had quite low pH, and there's also areas on the southern section which had quite high pH and high vigour, and the opposite examples, the opposite patterns in other areas. So we actually knew we were quite glad we didn't do any zoning, because we can see that there was patterns in here which are quite unrelated to our plant growth that we were seeing in the paddock. From there, the growers again set his own rates. In this case, this is his pH map over here on the left now, and this is a lime application map that he put out. He'd already ordered the lime here, so that was sitting in the paddock. He knew how much he already had, but was able to move that around to get the maximum benefit from the areas that needed it. This system, again, going to the point of having the right tools for the right job, the PCT system allowed him to link that prescription map to his John Deere operations centre, and he could send the variable rate prescription straight to the tractor from his office, so made his life very easy. Impact is, hopefully we're going to have a nice evening out of pH. He's done another one for phosphorus, which actually showed a very similar pattern to the pH. We're going to continue to observe that over time and see how it works. We'll do some more catch-up soil testing. But that example contained one really common pattern that we see. So in terms of correlating landscape with soil chemistry. Now, if I go back to this pH map, so the closer to the centre of this centre pivot irrigator was quite high, on the outside was quite low. This site has previously had a much smaller pivot on it. The centre of that smaller pivot was over to the left of the map, and it meant that those high pH areas corresponded with the previous pivot footprint. The low pH areas were outside that pre-existing pivot, so they were outside the commonly cropped area. So paddock history was actually the bigger variable here, instead of anything to do with our topography or soil type. So key lessons from those two examples are quite different, but they were tailored to specific needs for those two paddocks and those two crops. So we grabbed just the data we needed to target a decision like a key decision that we needed to make. It wasn't just a tire kicking exercise by any means. We were able to use the right tools to get the best job for that grower, and he's now able to take that over and can drive more and more of that himself. But just a final expansion on this idea of zoning versus gridding for soil testing data. It's one that we'll touch on probably in the questions later on as well. We find in our work that we get a lot of soils data. We've got a lot of EM38 data. We can model where water's going to accumulate or where it's going to shed. We find that actually can be quite well correlated to productivity, but poorly correlated to soil chemistry. Sometimes we're lucky enough it works, but other times it doesn't. So we're moving more and more to using a zonal approach when we know what our yield targets are going to be in different areas. So if we happen to have yield history that can help guide us on that, then we can actually fertilise zones based on a target yield, as opposed to assuming that they're going to have a consistent chemistry within those different zones. Takes a fair bit of data, I think, to get that right. It's an evolution where we're moving to, and I mean, we're looking forward to it. I think we're a little ways off here yet, but it's a good journey. So that's a couple of examples from down in Tassie. I'm going to throw it over to Tim Neale now, and he's going to run through a few examples himself. Thank you.
Thanks, Reuben. Appreciate the opportunity to come and talk to you today about some real rapid fire examples, just to give you a bit of a taste of what's possible. There's literally hundreds and hundreds of use cases, like was mentioned by Colin at the start. There's no one size fits all, and there is so many. Each paddock's got its own unique sort of opportunity. So I really want to just give you a rapid fire in the potential that's there. I guess the first example is one we just finished recently for a client, where he had budgeted 1.25 tonnes per hectare for gypsum across his whole property. So he had a fair idea about what in terms of budgets, and we find most customers have exactly the same issues, that they have a budget set aside, but where do I actually spend it? Where do I put for the biggest bang for buck? So we just created some variable rate prescriptions off last year's NDVI. Now, the NDVI is freely available to collect and use. Our platform delivers it every 5 days to any farmer in the world. You just got to create an account, jump on and have a look, and you can draw your fields in and actually get the data for free. And it's flying over very regularly, so it's got good opportunities to miss those cloudy days and also give you up-to-date information. So we just use that, a September image, split it into 3 zones, and in the end, we're only putting a light rate on the sand below red areas. Only needed a sniff of gypsum just for the canola. And then when we went up to the sort of heavy clay areas, which are much higher biomass areas, we were able to whack that up to about 2 tonnes. And on average, we used exactly 1.25 tonnes per hectare. So that's the good thing, is you can throw all those numbers in and it will, you can basically play around with your rates till you get your balance out. And we're able to give him each field how much he's going to need on each paddock and how much he's going to have left over, all before you start the job. So it really makes it a lot easier. And literally, we did 1,500 hectares of zoning in an hour. It's probably a bit of a lie. We went backwards and forwards a bit with some rates, but the thing is that it's a really, really simple entry point just using NDVI. It costs bugger all, and you've really got a great starting point for something as simple as gypsum on canola. So again, going back to the start, Colin's points about we're not necessarily trying to reduce the amount of fertilizer or ameliorant that we're using here. It's about optimizing for profit. So where's the best bang for buck for my use of my budgeted 1.25 tonnes a hectare of gypsum? Another example, this will rock your socks, I reckon. This is some EM work that we did on a client on the Darling Downs. If you look at the map on the right, this is the EM map from that field. Some areas, so EM measures clay content, moisture content, and salt content. It doesn't measure anything else other than that. So anything else you interpret from that is basically an interpolation of the data. However, we went and did soil cores and worked out why were the EM readings really high in these blue areas and why were they really low. So target your soil sampling. And a part of that was how much nitrogen's in the profile, as well as all those other factors I just mentioned. So the clay content, the moisture, and the salts. And this machine measures about 1.2 into the ground, 1.2 metres into the ground. And when we looked at the amount of nitrogen, because of the porous soils in those blue areas, there's an excess of 1,000 kilograms of nitrogen. I'm not talking about urea, 1,000 kilos of N sitting in that profile because he's been pumping N into that soil for 30 or 40 years and not been extracting it. And similarly, on the other areas of the paddock, there was nothing left. So the crop had used every drop of nitrogen. And this is the problem with the variability, is that the agronomist probably took a soil sample on there and said, if you average it out, it might have been 300 kilograms of N. And you say, well, that's enough. I don't need any more N, and away you go. So clearly, by understanding your soil type differences, you can get a better handle on things like extraction of nutrients. And so now we can spin around and do a vertebrate urea and a vertebrate gypsum map based on that EM map. Just convert that's point sort of data there, convert that into a shapefile, a polygon sort of format that will go straight into your vertebrate controllers, and most of those controllers will accept that shapefile now. Here's another quick example we've just done on a client that's recently purchased a protein monitor. I've been trying to hassle him for years to buy one of these, and I think it's already shown massive dividends. So you can see here, last year in the north, we had severely limited yield as a result of nitrogen. So severe deficiencies from flooding. The satellite imagery gave us hints well before harvest of what the crop was going to do, and you can see how well correlated the satellite imagery is peak growth in September. The yield map. Now the yield here varied from, in the red, 1 tonnes per hectare to, in the blue, 5 tonnes per hectare. So a 5-fold variation in yield. And in the protein, the lowest, the reds, were 6% and the highest were 12%. So most of the field had some sort of protein deficiency. So we were able to actually create a vertebrate prescription map based off protein only. And this is some of the work that the protein, the guys that make the protein monitors actually do, is to actually just to work solely on protein. And so now we've just provided a prescription map, which you just applied last week, with a massive trial strip through the middle. So we're really comfortable with what we're doing. That's really important. We need easy trials in here to actually make sure we're getting those responses and to make sure what we're doing is on track and we're getting good value for money. So we whacked a big trial strip down the middle. The average rate was around about 160 kilos of urea. And you can see there the rates varied from 50 kilos right up to 300 kilos. So, massive yield variation, massive protein variation. We're trying to bring that back under control, get it back to a stable yield and protein by upping those rates. That's a 6-fold increase in rates. So it was quite a bit of a scare for the grower, that's for sure. He was like 300 kilos, that's pretty high. So, but this is the kind of thing we can do now to actually bring that under control. And just a final example, and another one is actually going in the ground right now as we speak. We run the EM machine again over the country, and the EM soil zones are shown on the left, and the red areas are basically the lighter country, and then gradually gets heavier and heavier up to the blues. The blues are the heaviest country. So the agronomists went and soil sampled and took a whole heap of samples based on those zones. We showed very good correlations with phosphate, and as you can imagine, like phosphate rate generally changes with the soil type, and those lighter country definitely had a lot less phosphate in them. So we're able to produce a Starter Z prescription map there, 15, 30, 40, and 50 kilos based on those soil test results, and they're not grid-based samples; they're all targeted samples. We then again ran big trial strips through the middle of it, and he's farming this, north-south, so we have to make them fairly wide to ensure that we're when you run the yield monitor through, that you're actually capturing a clean bit of data in the middle. So we made these about 150 meters wide. So if you're running them with your strips, with your run direction, then you can make them probably around 100 meters is fine. We also then had to play around with some vertebrate seed. So we're doing some strip trials to see if we could actually run 40, 50, and 60 kilos of seed on that to actually, up that seeding rate. I think you need to up the seeding rate on those lighter soils to get them to tiller more, or to get more tillers per square metre. It might be different in your area, but that's what we're doing here. This example. But again, putting trial strips in, the variable rate makes it really simple to put these trial strips in. When we get the yield data, we're able to analyse that very simply without the grower really doing anything. So I'd encourage you to really put those strips into your variable rate maps as well. And the image on the right is actually over the weekend of the phosphate getting applied. That's the live map off my John Deere. So, another great example of where you can actually watch the as applieds coming in real time to make sure that job's going well. So thanks very much, and I'll hand over to Jamie.
Thank you, Tim. There was a lot of great ground covered there, and we have a number of questions coming through in the chat that we'll put to our panel now. So first up, we've got a question coming through from Nicole Baxter. What is the simplest system for making prescription maps? I might throw over to Reuben first, if you'd like to tackle that one.
Probably the key place to start is what your hardware is, what you're going to be using to apply it. That's the first place I'd start. As Tim said, most systems now will take a shapefile. A shapefile is just like the Word doc file of the mapping world. It's a really simple little system that allows you to bring your rates in per zone, and most hardware will have a converter for that. There's some really simple systems in John Deere, like they've got their Agrian system set up where you can bring in data fairly easily if you've got some good yield data or similar in your system there, or you can paint your own zones in there. Tim's system, data farming, that's always been a great first place to start as well. There's actually quite a lot of options out there. I reckon Tim's probably a good person to expand on that.
Yeah, I guess I'm a bit biased, aren't I? But no, I mean, this is, to me, Nicole, this is the whole problem with the precision ag industry. We've made it too complicated, and unless we get simplify it considerably, then we're not going to get adoption. And all of the precision ag software in the past has been built for specialised people. So we're on a journey to make it automated or semi-automated as much as possible. To use simple layers to create simple prescription maps so that people can actually get started on the journey. We don't want to start complicated. We've just got to do some simple things right so people get comfortable with how it all operates, and then they can move forward, and get more and more detail. And so, I think using satellite data is the simplest way of doing it because there's no humans involved. I guess, humans complicate things. And getting yield data is the ultimate measure, but it's often very difficult to get that. So, that's my take on it.
Yep. Thanks for that, Tim. It sounds like there's definitely quite a few options out there, which leads into our next question. How do you measure the economics of VRT compared to previous application methods and blank applications? Do you integrate test strips in the paddock, which you mentioned in your presentation, to act as a reference point each season? And where do growers start, I suppose, when it comes to integrating test strips?
Yeah, well, I think they're an absolute must-have, just to make sure that your response is what you're actually doing is getting the response you're hopeful. And you can put them in manually, or you can also put them in automatically into your prescription maps as you make them. So yeah, I think they're a critical way to actually measure that response. It's obviously, it's like I said, it's better to run them with your run direction. And you can get it probably down to, I like about 100 metres, but you could do 50 to 100 metre wide strips. Depends on the product, of course. You don't want to do that if you don't want a 200 metre wide strip of zero fertiliser. Not very economical. But you got to assess what that is. I think that if you're going to run them across the run directions, then you make them fairly wide, like 150 to 200 metres, because the yield monitor takes quite a while to come in and average. So you want to grab the middle bit of that data when you're analysing it. The key point about strip trials is put them in the right place. I see thousands of times where people have put strip trials in the wrong place. They're trying out some new product and they inadvertently put it down like the best area of the field, and then they don't get a response. Well, you find that you get better responses for certain things in the poor areas of the field. So number one thing is to start with some understanding of the field, whether it's a yield map, farmer knowledge, a satellite image, multiple years of satellite imagery, whatever it is. Start with some underlying knowledge. Put your strips in to cover high, medium, and low productivity areas. That's really important because I've seen it time and time again when people put trial strips in the wrong place.
Yeah, that's a fantastic point. You shouldn't be always putting them in either the best or the worst part of the paddock. It's good to get a good representation of the whole paddock there. We've had a question come through from a grower. What information do you need to be able to create the most accurate prescription maps that meets the crop potential in variable rate products across the paddock? I might throw to Colin for this one.
Thank you. So I guess the information you need is the information that's most relevant to what you're chasing. So understanding the crop potential, what is your limiting factor that you're trying to address? As Tim sort of said, it depends because every situation is different. It's a bit like each person is different, each paddock is different. The constraint is what needs to be understood. So if I use Tim's example of the sulfur of the gypsum on canola, for example, a single layer of information that was correlated with soil type effectively. So there was a spatial layer, there was some ground truthing involved, which was effectively the producer's own knowledge of the paddocks. The satellite imagery was giving a reference to the potential of that soil, and that's what was used to target that input. So I don't know if, Reuben, you want to add to that one in terms of the crop potential?
Yeah, thanks, Colin. So then just looking closely at that question, first comment I'd make is that even having something that's half accurate, it's usually better than doing nothing at all. So aiming for the most accurate or perfection can be you can end up going too deep into this, and just getting it half right is usually a whole lot better than doing a blanket application. We've got a problem down in Tassie, very, very little yield data that we can utilise. But yield history is a wonderful thing to be able to bring in, to be able to understand how a paddock performs historically. Look, I'm just going to echo you, Colin. Every paddock is going to be different. There's no one size fits all. So.
Yeah, thank you for your insights on that one. We had another question coming through. They said, we would like to see a future webinar where different tech is presented, either platforms or sensors or anything else in the market. So I think that question is more about what's on the horizon for precision ag at the moment. Is there any new software or technology coming through? I might throw over to Tim to start that one off.
Yeah, I guess it's there's been a lot of investment in ag tech in the last few years, so there's a lot of stuff coming, and I guess the next piece beyond that is how do you integrate, and I think that's where the market's at the moment. Is there's lots of things out there, but a farmer doesn't necessarily want to have 50 different pieces of software. So how can we work together better in the back end to enable this data sharing? So that's one of our key focuses at the moment, because we realise that there won't be one piece of software to do everything. If there is, it won't do all of those little bits very well. So we've all got to work together. So that to me is the push in the industry, and yeah, that's what I'm seeing. But happy to explore another webinar which goes through in detail each piece of software that's on the market and some of the in-cab stuff as well. I think that'd be a great idea.
Yeah, it'd be great to see some new sort of tech coming out and what's on the horizon there. We've had Andrew ask, how can we best utilise protein data in VRT decision making? It's a fantastic question. I might throw over to Reuben for that one, and then we'll go to Tim.
Very quick on this one, and handball straight to Tim. Without having much good yield data, we also don't have great protein data down here. So I reckon Tim's got some real world examples. He's the man.
Yeah. So with the advice that we've got is that we pretty much just ignore the yield and other layers. We are doing some soil testing based on the zones that come out of the protein maps. But really, we're just converting that protein into variable rate nitrogen or urea prescription maps. So based on how much percent protein you've got, and that tells you how far behind you are in terms of how much is nitrogen limited yield. And then you look at forecasting clearly what crop you're going to grow and what target protein percent is. So, X tons per hectare of sorghum or whatever by X percent protein gives me this much nitrogen required. And then just balancing based on that protein and to actually get that variable rate prescription map. There's quite a few growers with a lot of experience in this area. Someone like Reuben Holland, follow him on Twitter. He's got excellent examples of how he's managed to reduce his protein numbers now to all within 1%, just by using variable rate nitrogen based off protein maps alone. So he's a guy, and also talked to the guys that make the protein monitors. Their names just escape me right now. So yeah, that's our experience so far, and we're doing it at the moment. So we'll learn a lot more as time goes on.
Yeah, thanks for that. And for those growers that are deploying variable rate technology over a number of years, are you starting to see the paddock actually level out when it comes to in terms of nutrient and soil structure?
Yep, I can answer that one. We've actually done this. We've actually recommended growers go back to blanket rates, where they have basically fertilised their way out of the variability. We've seen it in rice, where historically there's been a lot of scalping, from land levelling, taking away a lot of phosphate in those sort of surface areas. We've backed it up with a lot of gypsum, manures, and phosphate, and now we're going back to blanket rates. Even that example I just gave, Reuben Holland, pretty much going back to blanket rates of nitrogen this year. So yes, you can fertilise your way out of this, but go back to our key point that we've all made. You've got to understand what's driving the variability first. Otherwise, you can create variable rate prescription maps all day long that don't actually respond to the problem that you've got. But where you do identify that problem and you can ameliorate or fertilise your way out of that problem, we have definitely seen where we've gone back to blanket rate.
Yep. Thanks for your input on that one. What are the steps for a farmer to access VRA? What are the advantages and disadvantages of real-time technology versus hiring a consultant to do the job? I might ask Colin first up to tackle that one.
Certainly. So in terms of real-time technology, I think what Jim's getting to is like data coming straight into the machine without being touched or interpreted by a human, and things going on. If, for example, you were doing real-time nitrogen detection or NDVI and having a variable rate on the go, I guess one of the disadvantages of that is not knowing where you're going to end up. There's not a target amount of fertiliser that you're going to be using. Again, to compare with Tim's example, they had a total budget, a total amount of gypsum to be applied, and worked it backwards. If you're using real-time sensors, that can be certainly one of the disadvantages, but you're taking a step out of the loop. The other disadvantage, I think, is taking out the logic. That the human element to it can be a disadvantage, because computers can make very accurate mistakes if they're not interpreted properly and they're relying on calculations that might be incorrect. So I would promote, yes, having a specialist involved, just like you would with financial management or high-tech mechanical issues. You need a specialist as part of your team to help you on that journey, and then depending on your own skill level, you take it on board like Reuben's clients have, or you keep using a consultant with a PA specialty as part of your team.
Yeah, it's definitely a great point. It's like that old computer saying goes, garbage in, garbage out. It's good to get that data right in the first place before you put it into software and start making decisions on it. We've got another question coming through, particularly around sowing. Have you found that elevation data from the machine during planting and tillage operations is sufficient, or do you need LiDAR elevation data? It's a good question. I'll throw over to Tim first for that one, if you've done any work in that space.
Yeah, like Reuben, I've done a lot of work in this space. Definitely planting and tillage is a perfect one, because you don't get any machine movement as much, and it's a narrow swath width. So it's totally fine to use that. You just got to be careful with things like harvester and spray rig collected elevation data, because the weight of the machine changes as the operation occurs. So you'll find that as the spray tank empties, the machine will lift up a bit. So that's one of the risks. Obviously, the other risk with any sort of machine data is wheel tracks. So you could be measuring the wheel track depth, not necessarily the actual elevation of the ground. So keep that in mind. But definitely planting and tillage is the perfect one. LiDAR is typically an airborne collected information every square metre. You'll get an elevation hit from the laser beam that flies over an aeroplane. It's the advantage of it is that you can see beyond the paddock, so you can see where water's coming into the field and where it's leaving the field. Whereas the tractor stuff is just where you've driven. So just keep that in mind. One final point before I flip over to Reuben is that we're working with a company who's just announced that they'll be collecting LiDAR data from satellites. So very exciting time ahead where we can collect, this kind of information much more scalable over large areas for anyone to access.
Thanks, Tim. I'm going to include a small answer to the previous question as well, of why one of the advantages of using a consultant to help with this kind of stuff versus a fully automated solution is that consultants or people specialising in the space, we've usually made all of the stuff ups, and there's lots of them that you can make on the way. So that makes it a lot more efficient because you can avoid those pitfalls. And it doesn't take much to make the whole chain in the data collection and processing and creating the prescription. It doesn't take much for that chain to fall apart. So understanding where those holes are is useful. In terms of the elevation data, obviously it depends on what you're using it for. Tillage data is great. The caveat I'd add to that is that we're dealing with, in Tassie, a lot of drainage planning. If you're doing tillage, the one thing you do when you get to a drain is you lift up your gear and then you pop it in on the other side, and that changes the relative height of your mapping gear. So you'll end up with some funky information just when you need it to be accurate. But I'd say the same thing about LiDAR. Because LiDAR is from a laser, if it's not done well, it's measuring the top of what it can see, not the top of the ground. So we have plenty of paddocks where the LiDAR data would indicate we've got every 24 metres a big ditch, but we haven't. We've just got a spray track. Or we might end up with a hill at the drain line just because there's a lot of weeds there. So it's measuring the vegetation, not the soil. That's a really nice example to me of places where somebody who's used a lot of the data can actually look at it and go, oh, there's a problem here. I recognise this problem. I've seen it before. No, we need to reject this data set and try something else.
Yep, thank you, Reuben. I've had a question around thoughts on VRT and EM surveys. Which modelled maps have been complementary to EM maps? Colin, have you had much experience with that one?
Well, can you just, rephrase, just state the question again?
Any thoughts on VRT and EM maps? Which modelled maps have been complementary to EM maps? That was the question on that one.
Okay. For me, an EM map is the guide on where to go looking further. I certainly treat with caution just using an EM38 map in isolation. Certainly like to tie them in with elevation data to understand how the terrain and the topography is related to soil texture. We know that generally speaking, heavier textured soils are down lower in the soil in the topography, for example. And yes, we use them to go digging, basically, either with cores or even a full soil pit. So I wouldn't base any VRT decision entirely on an EM38 survey at all. You need to link that with other information. It is just telling you that one part is different from another. It's isolating areas of similarity. You need to go and look at those. Tim, you want to add to that one?
No, I just fully support that, mate. Absolutely.
Yeah, thanks for your response on that one. Could you give details on where to get the NDVI satellite data from again? We might be able to put a link in the chat for that one.
Yeah, you can grab it from a number of places, but yeah, we offer it freely available through our platform, so you can just log onto our website and sign up there and add your fields.
Yep. We've had a question come through from Kimberly. She's interested to see the link between the use of VRT and the reduction on GHG emissions on farm. Is there anything out there that connects the dots at the moment? I'll hand over to Tim for that one.
Yeah, we've been working on this from a nitrous oxide situation from vertebrate nitrogen in crop. Obviously, there's a small percentage, I think it's a few percent, of our nitrogen applications in crop, especially on waterlogged soils, that will lead to nitrous oxides. And nitrous oxide is about 275 times more powerful than carbon dioxide in terms of atmospheric sort of greenhouse gas emissions. So obviously, a small improvement in that will lead to a very large reduction in greenhouse gas emissions. And this will become really, really important in the future when growers are questioning a lot more about their carbon neutrality. So we see that that's probably one of the biggest areas that we can work on because it's got such a big impact. But also on the other side, the soil carbon side, there's obviously potential there as well.
Yeah, thank you, Tim. We've had a question come through from Tom. What is the simplest, most cost-effective method for sampling a large broadacre area? And what is, we'll just get that one up now if we can, from Tom. Yep, and what is a sensible method for sampling / forming a base layer for VRP and K-maps? I can throw over to Reuben for that one.
How long is a piece of string question? And depends on what the value you're getting out of it, because you can go, the really simple is just use your gut feel and your knowledge of the paddock and go and test in zones separately, but that's pretty rough and ready. If you've got yield data, you can try a zonal process. The zonal process, once you've got some production zones, the benefit of a zonal testing system, so having preset zones and testing just within those, is that you need a lot less samples per hectare than you would if you're doing a gridded soil analysis. If you would have seen on the data I had, there's a lot of those data points were quite similar. Now, in theory, if we'd known that zone was already going to be there, well, we could rationalise those quite a lot and save on testing costs. But we didn't have any way of knowing that in this case. So you've got to have the information going in. If you haven't got that, then, I don't know, it's pretty hard to argue against just start with a grid and see where you go from there.
Yeah, thank you for that. A grower has asked, with a few years of variable rate fertiliser, do levels in soil even out to a point where constant rate is best in the future? Tim started to answer that one before.
Yeah, I think we've got that one. Yeah, we've certainly seen that it can go back to blanket rate.
Yep. How do you generate the best P prescription maps for the mallee? Is flat rate P a better option now, or do we need to flip the paradigm? If we are to get that question up, if that's okay.
Yeah, I guess the question there is response strips. That's what we've done in that mallee country, is run strips and see your responses. And yeah, it was absolutely startling to find the results. So again, get your base maps, understanding of variability, put your trial strips in to go through high, medium and low zones, and then measure that response in yield data. That's the best way of doing it. And we were blown away by the results. Yeah, and I think some people do also do just replacement P based on yield. That's another simple way of doing it.
Yeah, thanks for that. We'll take one more question from a grower. I want to convert New South Wales state LIDAR data to use it as a base for drainage. Is there any way to convert DEM format into a shapefile? I'll throw to Reuben for that one. If much experience with shapefiles?
Yes, there's multiple ways to do this. This is getting into fairly specialised GIS work, though. This is a really nice example of one of those points in the chain where having some specialist knowledge can be pretty useful. These things can be simple, or they can be heinously difficult, and it really depends on what program you're trying to send the data to. Are you after a shapefile to add as a guidance line to steer a tractor, or are you just after points to bring in to some drainage planning software? So yeah, it's possible, but it's a simple question to ask, but probably a horribly complicated one to answer.
Yeah. Thanks for your answer on that one. The topics today have generated a lot of interest, which is to be expected. We'll have to leave the discussions there. A reminder to provide feedback via the poll that will appear on your screen. I'll now hand over to Angelique for some concluding statements.
Thank you so much, Colin Hinze from Pinion Advisory, Tim Neale, Data Farming, and Reuben Wells from AgLogic for your contribution for today's webinar. I have a few very quick messages from the team at SPAA. Please save the date for the Australian Precision Agriculture Symposium on the 4th and 5th of September, which will be held in Perth. The symposium is run in collaboration with the University of Sydney and promises to bring together growers and researchers learning all the latest developments in PA. And before you sign up today, please take a quick moment to complete the feedback survey, which will appear on your screen soon. On behalf of all the team at SPAA, have a wonderful day, happy seeding, and see you all again soon.